Good morning, everyone. This is Narayan Reddy from the Department of ECE. First of all, let me welcome you all to the third BTech first semester. I hope you are all safe and staying at home. Be careful with Corona. In this semester, my subject is Digital System Design. The name itself represents here we are going to design some digital system, right? Already you studied the functionality of different combinational and sequential circuits, and also you design or you have seen the design procedure for different digital systems in the subject called STLD, that is switching theory and logic design. Once again, here also we are going to study the functionality of different combinational and sequential circuits, and we are going to design some digital circuits and systems. In addition to that, here we are developing a software program for all combinational and almost all combinational and sequential circuits. Why we are going to develop a program for combinational and sequential circuits, and what is the necessity means to enter our digital designs into the software environment. Why? What is the necessity? Why we have to enter our digital designs into the software environment means with the help of software tool, you can speed up our designs. You can speed up our designs and you can easily modify the system as per the user. That is the purpose of using software tools. Here we are using some language, HDL language, to develop program for our digital circuits, right? That is the simply the use of software tool. Now coming to this session, in this session I am going to cover the contents like outcome of the subject, content of the syllabus, what are the basic requirements to understand different concepts, what is integrated circuit, and what is logic circuit. Coming to outcome, the outcome represents our ability, what we can do after learning different concepts of the subject. So as per this subject digital system design, here I represented two outcomes. One is you can know various logic families used to design different logic gates. That is, you can understand, or first of all you can know different logic families available, their functionality, and using those logic families you can construct different logic gates. What is logic gate? Already you studied in the subject of STLD. The logic gates are basic building blocks for different digital circuits, right? Around 7 logic gates you studied, but they are all not a single components. They are the circuits. Logic gates are the circuits using components like diodes, transistors, resistors, etc. based on the components used, named as the logic family. Okay. Then another outcome is you can develop HDL program for combinational and sequential circuits. Okay. So these are the outcome of the subject. Then coming to syllabus, the first unit introduces what are the different logic families, mainly CMOS logic and bipolar logic, and how to interface these two logic families, bipolar logic family and CMOS logic families, right? Whereas in second unit you can learn one of the HDL language, that is Vhdl. What are the basic design elements available in the language, and what are the different basic models and how to develop program for combinational and sequential circuit, that you can see in the second unit. Coming to third unit, here we are going to study the functionality of almost all combinational circuits like decoders, encoders, comparators, multiplexers, some PLDs like PAL, PLA, PROMs, etc. And also you can develop a HDL program, how to write a HDL program for all these combinational circuits. Whereas in fourth unit, you can see the functionality of different sequential circuits like flip-flops, registers, counters, etc. And also how to develop HDL program for all the sequential circuits. Whereas in fifth unit, you can design some digital systems like barrel shifter, comparators, floating point encoder, and dual priority encoder. And also you can develop HDL program, and here you can see how to develop HDL program for all these digital systems. Okay, so this is the content of the syllabus in each and every unit of our subject. So by observing the content of this syllabus, the content of the syllabus, so you can understand that what is the basic knowledge, that is the concepts of STLD. If you have a command on the functionality of different combinational and sequential circuit, you can easily understand the concepts of digital system design, and you can develop easily the programs for all the combinational and sequential circuits. In addition to the concepts of STLD, if you have an idea of how to operate, what is the operation of bipolar junction transistor, of course PN diode, after that bipolar junction transistor, and then MOSFET. If you know the operations of these three components, mainly diode, bipolar junction transistor, and MOSFET, you can understand all these, the concepts of this subject very easily. And which subjects you need to, which books you need to follow for this subject means, these are the textbooks and reference books proposed by the university. From the textbooks, you just follow the book titled called Digital Design Principles and Practices by Walkerly. This book covers entire your syllabus. And coming to references, especially for the language, that is for the second unit, follow a book titled A Vhdl Primer by J. Bhaskar. Okay, so these two books are enough to understand and understand the concepts and to write the Vhdl programs. Okay. Then the another topic is, what is integrated circuit? Nowadays, if you observe any electronic system internally, you can see this type of components. This type of components only, that is called IC, simply called IC or chip. Okay, IC means integrated circuit. Okay, but previously the circuit appearance is like this. This type of circuit is called discrete circuit. Discrete circuit. Here you can identify each and every component or what are the different components are used in this circuit. Okay, but this type of circuits, that is discrete circuit, suffers with many problems like loose connections. Major problem is loose connection. Then the discrete circuits occupies more space, consumes more power, takes more time to do its their functionality. Okay, but coming to integrated circuit, all these components, whatever the components you observed in the discrete circuit, all these components are available in the single component, or appeared as a single component. Okay, So therefore, there is no chance for the loose connections, isn't it? Here, all the components are integrated in this, so that in the single component, appearance is single component like diode and transistor, so that there is no chance for the loose connections. Okay, and also it avoids other drawbacks of discrete circuits like space. The integrated circuit occupies very less space, here the speed of operation is very high and the power consumption is very less. That's why nowadays people preferring integrated circuits in their systems. Okay, so always the intention of the electronic engineer is reducing the system size. Not only electronic, that is okay. Of course, even people also preferring the systems which occupies less space. Okay, for example, if you take your mobile, okay, now which size of mobile you can prefer? It should be very smart. Okay, like that. Its speed should be very high. Okay, it has to consume very less power. Okay, so in the similar way, so that the integrated circuit satisfies all these requirements. So that's why nowadays people using integrated circuits are preferring integrated circuits in the systems. Okay, now coming to see the definition for the integrated circuits with reference to logic gates. The definition is a collection of one or more gates. A collection of one or more gates fabricated on a single silicon chip is called an integrated circuit. Already I said in the previously I said all the components of those discrete circuit, all the components of that discrete circuit are placed in a component in a single component, that is called integrated circuit, right? Now the definition is with reference to gates. It is defined as a collection of one or more gates fabricated on a single silicon chip, Okay, so what number of gates placed in a single silicon chip, that is called the integrated circuit. What are the other names? That is die. It is also referred as die, chip, or simply IC, die, or chip. That is the definition for the integrated circuit. Now coming to level of integration or levels of integration. So with the development of the technology of integrated circuits, more number of gates can be placed in a single silicon chip, so that they are classified as different levels, like small scale integration, that is SSI, MSI called medium scale integration, LSI called large scale integration, VLSI very large scale integration, ULSI means ultra large scale integration. Coming to small scale integration, so in this level only 10 to 12 number of gates are available per chip. Okay, so all logic gate ICs means AND gate IC, OR gate IC, NAND gate IC, NOT gate IC, those are all comes under this category, that is small scale integration. Okay, coming to medium scale integration, here around 12 number of gates are available in a chip. Under this category you can take the examples like basic combinational units, that is multiplexers, decoders, encoders, half adder, full adder, like that. Okay, those ICs comes under this level, that is MSA level. Then coming to another level, that is LSI called large scale integration. Here around 1000 gates are available per chip. Okay, so in this category you can take an example ICs like PLD devices, that is PAL, PLA, Those you can take an example for this level. Then coming to VLSI, that is very large scale integration. Here around 10,000 gates are available per chip. Microprocessors, basic microprocessors are the examples for the VLSI. And coming to ULSI, here more than 100k gates are available per chip. Okay. And now let us see what are the packages, or in which package usually the IC can appear. The different packages and their and you can see their shapes like this. Okay, so this package is called dual inline package. It is very popular package, dual inline package. This is called transistor outline package, and this package is called quad flat pack, whereas this is called plastic leaded chip carrier package, and this is pin grid array, and this type of package is called ball grid array. Okay, so like that the integrated circuits are available. The choosing of the type of package is one of the requirement is the number of pins. Okay. Then coming to logic family. What is logic family, and the classification of logic families that you can see now. I said already, based on the components used to construct different gates named as logic family. Okay. So that is, logic gates are not the component directly like diode transistor. Okay, they are all circuits. The circuits constructed using diodes, transistors, MOS transistors, resistors, etc. Okay, so based on the components or type of elements used, named as the logic families. Okay, so now see the definition. Logic families are groups of logic circuits. Logic families are groups of logic circuits that are based on particular type of elements. The elements may be resistors, transistors, etc. Okay, and now see the how one logic family is differ with another logic family means based on the different parameters. The parameters like it may be speed, power consumption, cost, different voltage levels, current levels used for representing logic 0 and logic 1, etc. So these are the parameters usually used to differ one logic family with the another logic family. Okay, then coming to classification. So broadly the logic families are two categories, that is bipolar logic family, MOS logic family. Okay, the broad classification of logic family is bipolar logic family and MOS logic family. Let us see the subclassification under this bipolar. There are diode logic, diode transistor logic, resistor transistor logic, TTL, that is transistor logic, and another one is ECL, that is emitter coupled logic. So diode logic means here only the diode is the main component in this case, whereas in DTL, that is diode transistor logic, here the main components are diodes and transistors. And coming to RTL, that is resistor transistor logic, here the components are resistors and transistors. Okay, and another bipolar logic is TTL, that is transistor logic. So here only bipolar junction transistors are used. Okay, whereas in ECL the expansion is emitter coupled logic, but here also we are using only bipolar junction transistors, but we are maintaining an emitter coupling. Okay, so based on the type of components used, the different bipolar logic families are this: diode logic, DTL, that is diode transistor logic, RTL means resistor transistor logic, next TTL means transistor logic, and then ECL, that is emitter coupled logic. Similarly, before going to see the subclassification on MOS logic, so remember one a very important point is, out of all bipolar logic families, the very popular family is TTL. The very popular family is TTL. Okay, why? Because that you can see in the further classes. And the fastest logic family out of all means out of all bipolar logic families and MOS logic families, the fastest logic family is ECL, emitter coupled logic. Okay, suppose if you want to operate the system very fastly, you need to go for which family gates? That is ECL family gates. ECL family gates. Okay, but the popular one is TTL. So with reference to all parameters, almost the TTL is the popular one. Under which logic family? Bipolar logic family. Under bipolar logic family, TTL is the popular one. Okay. Then coming to MOS logic, let us see the sub-classification here. One is NMOS logic family. NMOS logic family. Okay. Here in the case of NMOS logic family, only NMOS transistors are used. Okay. And another sub-classification is PMOS logic family. PMOS logic family. Here only PMOS transistors are used. Then coming to CMOS, the expansion is complementary metal oxide semiconductor. Complementary metal oxide semiconductor. There is no transistor of named as CMOS like NMOS and PMOS, but what it is means, the word complementary is it uses both NMOSs and PMOS transistors. Okay, that is called CMOS. CMOS means it includes both NMOS transistors and PMOS transistors. That's why named as complementary metal oxide semiconductor. So these are the different families under MOS logic. Out of all these MOS logic families, CMOS is popular one. CMOS is the popular one. Not only out of MOS logic, out of all logic families, the popular logic family is CMOS. Why? Because it consumes very less power. Okay, it takes very less power. Okay, so based on the user requirement, suppose if the requirement is very fast, operation, what is the preferable family? That is ECL. Okay, suppose if the requirement is power consumption is very less, the power consumption should be low, which family you need to go? That is CMOS. Okay, CMOS. Okay, so that is the classification of logic family. Okay, so let us see once again what is IC. How can you define an IC with reference to gates? So IC means a collection of one or more gates fabricated on a single silicon chip. Single silicon is called integrated circuit. Okay, then coming to logic family means based on the type of element used, they are grouped and named as logic family. Okay, how different logic families are differed? Based on the parameters like speed, power consumption, cost, and voltage levels and current levels, also cost. Okay, and the classification is mainly two classes. One is bipolar logic family and another one is MOS logic family. Okay, and these are the subfamilies under bipolar logic, and these are the subfamilies under MOS logic. Out of all logic families, widely used logic family is CMOS. Under all bipolar logic families, very popular family is TTL. Okay, out of all logic families, the fastest logic family is ECL, that is emitter coupled logic. Okay, good, thank you. And in the next class we can see about CMOS logic family. Okay, what is the structure of CMOS logic family, and how to develop different gates using CMOS structure, that you can see in the next class, right?